Hey guys, welcome to question MM435 of the Maths Methods Fortify study guide. So we've got this question that says there are two restaurants which operate right next to each other, Restaurant A and Restaurant B. 94% of the meals that Restaurant A sells are considered to be of good quality, while 98% of the meals that Restaurant B sells are considered to be of good quality. Every day, Restaurant A sells 150 meals and Restaurant B sells 200 meals. Paige is a regular customer of each of these restaurants. Each day, she chooses one of these restaurants to eat at and she has dinner there. Now part A, which is a 2-mark question, says on any given day, what is the probability that Paige's meal is not of good quality? Alright, awesome. So the fact is that Paige could go to either one of these restaurants on any given day, and she could also have a good or bad quality meal at either of these restaurants, alright? Whether she has a good meal depends on what restaurant she goes to. So immediately what we need to figure out, or immediately what we need to recognize, is that whenever we have something that's conditional probability like this, like if she goes here, the meal's going to be bad, if she goes here, the meal's going to be good, that's when we should use a tree diagram. Okay, so as soon as we see this conditional probability stuff, tree diagram. So on any given day, Paige can choose to go to Restaurant A or Restaurant B. If she goes to Restaurant A, she can either have a good quality meal or not a good quality meal. If she goes to Restaurant B, same thing. It can be good quality or not good quality, right? Now, Restaurant A sells 150 meals and Restaurant B sells 200 meals, okay? So out of the total meals sold, there are 350 meals. Restaurant A sells 150 out of these 350, and B sells 200 out of these 350, right? So they both total to 350. Now, if Paige randomly chooses one of these meals, she's going to be one of these meals out of these 350, right? Which means that her chances that she's eaten at A is 150 out of 350, and her chances that she's eaten at B is 200 out of 350, right? This is equal to 4 on 7, just to make this a bit more simple to read. And the top one is equal to 3 on 7. So if she eats at A, she's got a 94% chance of having a good meal, which is a 94 out of 100 chance, right? Simplifying this is 47 on 50. If she's got a 47 on 50 chance to have a good one, she's got a 3 on 50 chance to not have a good one, right? Because these two have to equal to 1. Now, if she goes to Restaurant B, she's got a 98% chance to eat a good meal, which is 98 out of 100, which is 49 out of 50. If she's got a 49 out of 50 chance to eat a good meal, she's got a 1 out of 50 chance to eat a not good meal at Restaurant B. This is our first mark. Drawing this tree diagram gives us a mark. So now what? Well, we're looking for the probability that her meal is not of good quality. So she could have either gone to Restaurant A and not got good quality, which is this path here, or gone to Restaurant B and not got good quality, right? So in order to figure out the probabilities of each of these paths, we need to multiply these pathways together. So the probability that she had a not good quality at Restaurant A is 3 on 7 times 3 on 50. That's the probability that she didn't get a quality meal at A. The probability that she didn't get a quality meal at B is 4 on 7 times 1 on 50, right? So then we get 9 on 350 plus 4 on 350. Awesome. Which is 13 on 350. Sweet. Now that is actually our final answer. Now if you had if you had 7 on 175 as your answer, that's actually a typo on our part. That should be 4 over 350, and then they should add to 13 on 350. So this is the correct answer. That's your second and final mark for part A. Let's move on to part B. Now part B says Paige's meal on a particular day is not of good quality. What is the probability that she ate at Restaurant B that night? Awesome. So part B this is just a 1-mark question. B. So we're looking for the probability that she ate at Restaurant B, given that her meal was not good quality, right? Because it's told us on a particular day that the meal is not good quality, right? So that's a given, okay? So according to our conditional probability formula, probability of B given not Q is the same as intersect B intersect not Q over the probability of not Q. The intersect of B and not Q is B here and not Q. Okay, so we multiply these two together to get that. So we get 4 on 7 times 1 on 50. That's our intersect. Over the probability that's not good quality, which in the previous question we found to be 13 on 350, right? Now we've got 4 on 7 times 1 in 50, which is 4 on 350, divided by 13 on 350, which is the same as, actually we'll do it down here, 4 on 350 multiplied by 350 on 13, which is equal to 4 on 13. Now answer there is 4 on 13, that's our, it's only a 1 mark question, so that's our 1 mark. Guys, that's it for part B, and that actually wraps up MM435. If you have any questions about any of this, please let me know in the comments below. But otherwise, thank you for watching, and I'll see you in the next video.